Hey guys, uh, welcome to beginning algebra. In 1.2, we're going to cover fractions in algebra. Let's get after it. All right, so when you see a whole number next to a fraction, this is what we call a mixed number. Okay, and unless you're dealing with cooking and recipes and stuff like that, mixed numbers aren't really helpful. So if you ever see one, your best bet, if you're trying to work with it, simplify it, or anything like that, is to convert it into an improper fraction. So how you do that is you simply take the denominator, the bottom of the fraction, which is 8, and you're going to multiply it by the big number. In this case, 1. So 8 times 1, and you're going to add the numerator. So 8 times 1 is 8, plus 1 is 9. So this is going to be 9 over 8, and that's how you convert a mixed number into a improper fraction. And you can go the other way too. Cycle number 2. How many times does 5 go into 2 evenly? 2. Because 5 times 2 is 10, with 1 left over, so it'd be 2 and 1/5. Okay, 2 and 1/5. Okay. Um, Now, a lot of times when it comes to factoring, you need to know if a number can factor. And otherwise, you need to know if a number is prime or not. And in this case, excuse me, in this case, if you know your divisibility rules, that's helpful. If you don't know, I would encourage you to look them up. Uh, because each there's divisibility rules of 2, 3, like all the numbers greater than 1. So I would look those up. But that's just to see if it factors. But your prime numbers are like 2, 3, 5, 7, 11, 13, stuff like that. Definition of prime is anything that has 1 in itself as a factor. Okay, so if the question asks you what is the prime factorization of a number, then it wants you to write out a product of whatever that is using only prime numbers. Okay, so typically when I see something like that, I'm going to do a reverse division kind of thing. So 2 doesn't go into it. 2 is my smallest prime number, and that's where I would start, but this was not even. So I'm going to move it to 3. 3 goes into this. Let's see, 14. It's going to be 2, sorry, 4, 2 left over. So it's going to be 27. That's going to be 49. And that's going to be 7 and 7. So you notice it jumped to 7 and 7. Uh, I use 3 typically until I can't use it any further. And 3 doesn't go into 49. Uh, so one of the divisibility rules for 3 is that if all the digits, in this case 147, if all the digits add up to a number divisible by 3 or a multiple of 3, then it is divisible by 3. So 1 plus 4 is 5, plus 7 is 12. 3 goes into 12, so it works. It's kind of magic if you think about it. But typically I would divide by 3 or 2 until I couldn't do any further, and then I would go to the next highest one. Like I said, this one wasn't even, so I started with 3, and I used 3 once. And after I used 3 once, um, I could have used 5, but 5 doesn't go into 49, and so move on to 7. If 7 didn't work, and move on to 11, so on and so forth. But here I have everything, and then now everything on the outside is prime. And so I'm going to write this as 3 times 7 times 7, and that's what they wanted. So there's that. Okay. Now, 127, uh, 7 plus 2 is 9, plus 1 is 10, so 3 doesn't go into it. And you could try several numbers, but if a number is the only factors are 1 in itself, then it is prime. And that's exactly what happens here on number 4. It is prime. Okay. Now, another thing with fractions is you're not done unless it's in simplest form. So if you can still factor, or if you can still reduce, you have to keep going. Otherwise, it's wrong. All right. So I would always at least try, even if it's not obvious, try. And if your calculator gives you like a decimal or something, then that's great. You don't have to do it. That's great because you don't have to do anything. But if it gives you a simplified fraction or anything like that, um, all is well. So here, I know 5 goes into any number that ends in 5 or 0. So 5 goes into both of these. 5 goes into 35 7 times and 48 times. So 7 over 8 is my reduced fraction. One thing I will say about the calculator, though, is if you just say something like 5 divided by 3, um, it's going to give you a decimal, most likely. Uh, but you can ask your scientific calculator to convert it back to a fraction, and it will do that. And if it was already simplified, it'll give you your original back. Or if it could have been simplified, but it's still giving you the decimal form, it'll give it to you in the simplified form. And if you have questions about that, just reach out and we can talk through how to work through your particular calculator. I'm not going to give a blanket answer because we don't all use the same calculator, but I can help you work yours if you have questions. Um, okay, so here, when it comes to multiplying fractions, you simply multiply across the top and across the bottom, reduce if you can. So 5 times 1 is 5, 2 times 7 is 14. I can't reduce. And the great thing about this is that if I could have reduced here, that means I could have done some kind of reduction over here. I can't, but that's what it would have. That's what it would have. If I couldn't have factored at the beginning, then I can't factor at the end. But if I can factor at the end, then I could have factored at the beginning. I hope that's not too confusing for you. All right. So I mentioned earlier on our first problem that unless we're dealing with cooking, we don't really have a lot of use. Sorry, we don't really have a lot of use for mixed numbers. So we're going to convert these into improper fractions. So 6 times 4 is 24, plus 1 is 25, so that's 25 over 6 times. And then 5 times 2 is 10, plus 2 is 12, so it's going to be 12 over 5. Okay, all right, so this is what I was saying. If it can factor, if it can, if it can reduce, you can do it early, or you can multiply, uh, and then reduce. But as you can see, if I try to wait and reduce later, it's not necessarily going to be obvious because my numbers are going to be big. Because 25 times 12 is going to give you like 300, which is bigger than most. So let's take a look. Let's see what we have on top and what we have on bottom. So 6 doesn't go into 25, but it does go into 12. So I can take 6 and say 6 goes into 6 one time, 6 goes into 12 two times. 5 goes into 5 one time, 5 goes into 25 5 times. All right, and then now I just take my reduced numbers and multiply them across the top, across the bottom. So 5 times 2 is 10, and then 1 times 1 is 1. So that would technically be 10 over 1, which is just 10. Okay. On number 8, when it comes to dividing fractions, you multiply by the reciprocal. You take any division problem when it comes to dividing fractions and divide by its reciprocal, or you force it into a multiplication problem. So this is 2 over 9 times 7 over 9. Now, this is where it can be tricky because as a division problem, it looks like something I can reduce. However, when I change it to a multiplication, I can't reduce anymore because all my nines are on the same level. And so that doesn't work. So multiply across the top, you get 14. Across the bottom, you get 81. And that's it. Okay. Now, uh, problems like number 9 can be tricky because you have a whole number. But you have to remember any whole number is understood to be over 1. And so when I rewrite this, it's going to be 3 over 1 times 5 over 9. Again, reduce if you can. So yeah, 1 and 3. 3 goes in 3 one time. 3 goes into 9 three times. Um, you have 5 over 3. Easy peasy. When it comes to adding fractions, whether you're adding or subtracting fractions, you can only do so if you have common denominators. And so if you don't have common denominators, you have to work to get them. But if you don't, or if you already have common denominators like you do here, it's going to be 6 over 12. You just add or subtract across the top. Once your denominators are the same, you don't touch them again. And you work across the top. In this case, 1 plus 5 is 6. That's going to be 6/12. And again, like before, if you can reduce, you must reduce. Okay. All right. On 11, we have to get common denominators. Okay. Now, you want to look at them because if one goes into the other, then I only need to fix one of them. But neither one of them go into each other, then I got to work on both of them to get them to something that I can use. In this case, 4 does go into 20. So all I need to do is multiply uh, the top by 5 and the bottom by 5. Essentially, what does it take to get 4 to be 20? What am I multiplying by 4 to get 20? Okay, so that's going to be 15 over 20 plus 3 over 20 equals 18 over 20. Now, 18 over 20 can reduce. So even though you're doing all this work, you still have work to do because it can reduce. 18 over 20, that's going to give you 9 over 10. You just take 2 out of each of those, and all is good. Um, 12. Again, I would convert these into improper fractions. Um, so that's one way to do it. And if you did that, that would be 18, be 20 over 3 minus 8 times, or 4 times 2 is 8. So it's 9 over 4. So this is what you'd be working with, and you have to convert both. Um, so let's do that. 3 doesn't go into 4, 4 doesn't go into 3, but 3 and 4 both go into 12, and that's the smallest number, smallest multiple that both of them go into. So I'm going to take the first one, multiply it by 4 and 4. And then I'm going to multiply 3 over 3. Okay, now let's clean this up. It's going to be 80 over 12 minus 27 over 12. And again, once I have my common denominator the same, I don't touch the denominators anymore. I strictly work with the numerators at this point. So this is going to be 80 minus 27. Well, that's going to be 80 minus 20 is 60. So it's going to be 53 over 12. Now, at this point, depending on how they want the answer, you could plug in 53 over 12, or you could rewrite this as a mixed number. They gave you a mixed number, started with mixed numbers. They might want you to end with mixed numbers. So you can, 12 goes into 53 4 times. 12 times 4 is 48. 53 minus 48 is 5. So that's going to be 4 and 5/12. So whether they accept an improper fraction or they want you to give a mixed number, that's how you would do that. Okay, on problem 13, all it's asking you to do is take 17. So if you see this this semicolon, anything after that, it's asking you to plug it in and see if it works. Is there a solution? Meaning, does one side equal the other? So I'm going to plug this in. So it's going to be 1/2. 17 minus 3 equals 1/5. 17 plus 8. And really, this is more of a question. Does it equal? So let's keep playing. So we got 1/2, 14, 1/5 of 25. Okay, half of 14 is 7. 5 goes into 25 5 times. So you ask yourself, once everything is all said and done, is this true? Is it true? Does 7 equal 5? Well, no, 7 does not equal 5. So this would be no solution. No solution or not a solution. Okay, it doesn't work. Doesn't work. Okay, right. And then you will most likely encounter some of these problems where you have to convert it from English into algebraic, English into math. So you need to be able to read this. And this is a number decreased by 1/6 is half of that number. Okay, so decreased by or less than or anything like that, that is subtraction. And so I'm going to say x um, decreased by 1/6 is, that's equals half of that number. So 1/2 x. All right, sometimes when you work this out, there is work like number crunching that you can do here. Once you set it up, that's it. You can't really do anything with that. On number 15, it says the product of 3/8 and a number, so 3/8 x is increased by 5. So increased or added to, that's always uh, x plus 5. So it says the product of 3/8 and a number increased by 5. Right, so it's subtle, but it's asking you to add the 5 first and then multiply. This is the product of 3/8 and a number increased by 5. So the and tells you where to put that parentheses, and a number x increased by 5. Okay. Right. And then last one, we have a subtraction inside the parentheses, and then we have to divide by 2/3. So inside the parentheses, we need to get common denominators. All right. So I'm going to need to multiply the right side by 5 over 5, and the left side, or the left side by 5 over 5, the right side by 3 over 3. All right. So it's going to give me 10 over 15 minus 6 over 15 divided by 2/3. Okay, so 10 minus 4, or 10 minus 6 is 4, so it's 4/15. divided by 2/3. Now you can go ahead and write divided by 2/3, or you can change it to the multiplication that we're going to do. And so multiply that by the reciprocal. Now, 2 goes into 1 time, 2 goes into 4 twice, 3 goes into 3 1 time, 3 goes into 15 5 times. And so at this point, I'm going to 2 times 1 is 2, 5 times 1 is 5. And that, ladies and gentlemen, is my answer. Okay. Thanks for joining me in this lesson, and I'll see you in the next one.